students, I welcome you to today's computer class. Today we're going to be learning number bases. It's going to be a review, as you know that this topic was introduced to you during our last term. So it's going to be a quick review, and we'll be basically seeing how we can convert from one number base to another, as we did not have adequate time for that. But let's start by seeing what number bases are. Once again, a number base, which we can also refer to as base, refers to the unique or different symbols and notations that they use to represent value. Now let's look at the different number bases. Here we are going to be considering 4. There are other number bases which you'll be learning in mathematics, but we are looking at these 4 due to their unique nature, as they are all expressed in base 2, except base 10, which we are using to be able to convert from one base to the other. A quick reminder of the different number systems and their digits will remind you of what each base entails. For example, the binary, we said, are numbers in base 2, therefore only 2 digits are allowed, like you have displayed on the screen. Octal, which is base 8, allows 8 digits, and the decimal allows 10 digits, that is from 0 to 9. Then hexadecimal allows 16 digits, since it's in base 16, 0 to 9, and the first 6 letters of the English alphabet, just as we have it displayed on the screen. You will remember that A is equal to 10, B 11, C 12, D 13, E 14, and F 15. Okay, now let's see how we can convert from one base to another. We'll see how to convert from decimal to other bases. To convert from base 10, which is decimal or denary base, to other bases, you need to divide the number in base 10 continuously using that particular base that you are converting to. Now let's have some examples. Assuming we are converting 215 in base 10 to base 2, like I said earlier, we will be dividing using the required base, which is base 2. As you divide, take note of your remainder. For example, 215 divided by 2 will give us 107, remainder 1. If you divide that again, you will have 53, remainder 1. Divide again, 26, remainder 1. 13, remainder 0. 6, remainder 1. 3, remainder 0. Divide 3, you will have 1, remainder 1. And finally, since 2 is bigger than 1, you are going to be having a 0, and the 1 will remain. Then you will read from the bottom to the top to have your answer. Now, what is our answer? 1101 0111 in base 2. Another example is 357 in base 10. Now we are converting to base 8, and so we'll be using 8 to divide. If we divide 357 by 8, we'll be having 44, remainder 5. Divide again, you have 5, remainder 4. And since 8 is bigger than 5, we shall be having 0, remainder 5. Like we did earlier, we'll be reading our number from the bottom to the top. And what does that give us? 545 in base 8. Beautiful. Let's have another example still. 298 in base 10 to base 16. Converting this to base 16 also means that we are dividing by 16, as shown on the screen. We shall be having 24 if we divide the first time, remainder 14, which you remember is equal to E. If you divide 24 again, you have 1 remainder 8. And since 16 is bigger than 1, we shall be having 0 and the 1 will remain. Finally, we'll read our number from the bottom to the top to have our answer, 18E. Now let us proceed to converting from other bases to base 10. To do this, instead of dividing like we did earlier, we are going to be multiplying. I do believe you still remember how to multiply. To convert from any other base to base 10, we are going to be multiplying each digit by the base. After multiplying, you are going to be giving the base powers from right to the left. The first power will be 0 and you keep increasing it by 1 before adding together the result. We have some examples here that will help us understand this better. Let's convert 10110010 in base 2 to base 10. As earlier said, the first thing will be to multiply each digit by the base. In this case, the base is 2. And then we'll be increasing our power from right to left. That means the last base, which is the last 2, will be given power 0, then 1, 2, 3, 4, and you go arithmetically like that until you get to the very first number. And since we have 9 digits, the first base there will be given power 8. Next, you are to multiply each digit by its base number. Take note of the powers which we have already indicated. Now look at the last 2. You can see the power is 0, the next is 1, the next is 2, 3, 4, 5, 6, 7, and then 8. Finally, you add up the result. 2 raised to the power 8 means 2 multiplying itself 8 times, and that will amount to what? To 56. The next is 0, the next is 64, and so on. Finally, the answer is 357 in base 10. The second example is 405 in base 8. We are converting this to base 10. Give them the appropriate power. Finally, evaluate that. 8 squared is 64. And anything multiplied by 0 is 0. And anything given the power 0 is 1. So we have that. Another example is BAD in base 16. We are converting this to base 10. Don't forget the value of each of these alphabets. Again, indicate the power so that you remember what power to give to the bases. The last 16 has power 0, the next is 1, and the next is 2. By the time you multiply those, you will be having the values displayed on the screen. Finally, add up what you have. What would that amount to? 2989 in base 10. Okay, we are gradually coming to the end of the class, but just before we go, let's take a quick summary of what we've discussed so far. In this lesson, we have seen that a number base is a number of digits or combination of digits that a system of counting uses to represent numbers. Secondly, we have seen that the base of any number is usually written beside the number at the down part, which I told you we call subscript. For example, the 8 displayed beside 17 shows the base, which is read as 17 base 8. which of course can be converted to any other base. Yes, we have seen that we can convert from one base to another depending on the one being used at any particular time and place. For example, we can convert from decimal to other bases and from other bases to decimal base.
Thank you and see you soon. Bye.